So this section is kind of a catch-all on more stuff about precipitation and condensation. Generally, when we use the term cloud burst, that means just basically a sudden, heavy amount of precipitation, liquid precipitation, rain falling from one of the two types of clouds we said that produce rain. Remember, cumulonimbus clouds have a fair bit of vertical development, and nimbostratus clouds would be kind of low-level precipitating clouds. We know they're rain clouds, just to remind you, because they have the word or the kind of the root NIMB in them. Just kind of some miscellaneous stuff about precipitation. The next slide has a table from your textbook that kind of talks about the different types of precipitation in terms of kind of size. Mist would be the smallest size of kind of liquid precipitation, literally falling from the atmosphere to the geosphere. And of course, since it's the smallest, it has what the slowest terminal velocity, doesn't it? And rain would be the greatest of these, drizzle somewhere size in between. Virga is kind of cool. You know how we said usually clouds have flat bases because that's marking what we call the lifting condensation level. Well, if you see clouds kind of dripping like this, can you see it kind of just, okay, what's happening is that drip actually is the cloud is dumping. The cloud is going ahead and it is precipitating, but instead of that liquid water reaching the ground, basically that liquid water goes ahead and again evaporates into the air before it hits the ground. So virga is rain that doesn't reach the ground. This is the table I was telling you about that shows you the different sizes of precipitation. This table goes on then to talk about the different types of precipitation. Of course, whenever you see glaze, I'm hoping you think freezing rain. And these two, sleet and freezing rain, I'm hoping you think temperature inversion. Let's see, where is it? I don't see it right off the top of my head, but temp inversion. Then it goes on to talk about rime, and I have a picture of rime here in a minute. Rime is basically heavy frost. We talked about snow. Snow falls from cold clouds, and the temperatures between the cloud and us continues to be cold enough so it doesn't melt. Hail, we haven't talked about hail. I have a slide coming up. Actually, hail is only associated with cumulonimbus or CB clouds. Cumulonimbus storm clouds may or may not give you hail. And grapple, actually grapple, when I talk about hail, I also kind of talk about grapple. So just a little bit more about snow. Because of the structure of a water molecule, when water solidifies, we under those awesome conditions in the clouds to form snow crystals, we get these beautiful six-sided shapes. Doesn't mean that they're how do I say? They are all unique. I was going to say that doesn't mean that they're all identical. Snowflakes are not. It's true. And I'm going to show you some different types of ice crystals, and you'll get different types of ice crystals depending upon the temperature and moisture conditions. And as we talked, as an ice crystal or snowflake falls through the cloud, it can pick up buddies in something we call accretion and get larger. And as you know, there's different types of snow. I mean, there's like the powdery stuff, and there's kind of the wet stuff. Okay, so these are the different shapes, major different shapes, and it goes ahead and shows you the temperatures that you're generally going to get those shapes at, okay, within the cloud. It's just some pretty pictures. It's amazing, back in, goodness, I don't know if it was the early 1900s, but there was a photographer who, and photography was kind of a tough thing back then, who would go out and photograph snow crystals. Just amazing. Again, sort of a miscellaneous slide showing you another figure to show you freezing rain or sleet event. Remember, what they both need is a temperature inversion, and this is on the slide. They both need a temperature inversion, and one good way to get a temperature inversion is basically what we call overrunning of a warm air. We already looked at how one lifting mechanism is what we call frontal wedging, and basically the cold air is dense and it wants to stay down. The warm air then is light, and when the warm air then can be shoved up and over. And notice if we have like a chunk of warm air shoved up and over, that's where we can go ahead, I don't know where to circle it necessarily, that's where we can go ahead and get this temperature inversion, where that warm air goes ahead and causes the snow to melt, and then when it falls through this cold air pocket here, it can go ahead and refreeze. And depending upon the depth of the amount of time it has to refreeze, we'll either get sleet, little ice pellets, or we'll get freezing rain. So this again is to show you the freezing rain event. Oftentimes with this frontal wedging, of course, they're associated with a front, and you can see, we'll talk more about fronts, but the blue line here is showing cold air is headed this way, and the red line here is showing you that warm air is headed this way. This is actually an example of what we call a stationary front, and that overrunning is called cause a temperature inversion. And this is a photo of your freezing rain, freezing on contact event. Must have been a shallow temperature inversion. So I want to mention hail. And hail, I said you need some sort of thunderstorm going on. And the cloud associated with thunderstorms are cumulonimbus clouds. And what we're going to see here on the next figure is that this little, what we call a grapple, an ice pellet. Now this isn't a nice cool snowflake. It's a solid chunk of ice, a grapple, that can form in cumulonimbus clouds. It's carried up and down the cumulonimbus cloud. And as the grapple is carried up and down the cumulonimbus cloud, it cycles, and I'll kind of show how it catches an updraft and then it falls, and it catches another updraft and it falls. And as it moves around about the cumulonimbus cloud, it's coated by supercooled water. And as it gets large enough, it'll fall back down and hit your car. No, kind of kidding. Okay. At some point, this whole coating process makes the hail or hailstone large enough that it goes ahead and falls from the cumulonimbus cloud. So if you were able to look at a hailstone, I have a picture here in a minute, they kind of look like an onion. They've got these layers. And the reason they have layers is because they've gone up and down and up and down, and they get coated on the outside. Now, how heavy does it have to get before it falls from the base of the cloud? Well, it has to do with something we call, it has to do with how strong that updraft is. Remember a little bit ago when we were talking about precipitation, I said that liquid water droplets need to get heavy enough in order for their gravity to overcome this updraft. If we have a strong updraft, that means your hailstone can get pretty darn large before it falls. So here's our cumulonimbus cloud, just to kind of talk you through this. That red line, we'll be talking more about this when we talk about severe weather, but this is the updraft. Literally, it's air relocating from lower elevations up. And here is our downdraft, over here in blue lines. Now, associated with our downdraft is our precipitation, but let me go ahead and denote, here is our freezing point. So this would be what? A cool cloud, wouldn't it? Because we have the Bergeron process going on up here, and we could have the collision coalescence process going on down here. In a normal cloud, that's kind of how it would be. But notice we've got some mixing going on with our updraft and downdrafts. So I mentioned grapple. There's a grapple forming up here in our solid place. Now, kind of a failed ice crystal. And notice the grapple then can come down. Notice this figure showing it come down, go up, come down, go up, come down, go up. And it's kind of catching different updrafts. And then gravity kicks in that catches another updraft. But each time it goes down and comes up, it is catching, it can be coated with more supercooled water. And so here is, actually, this to me looks more like your, just like a precipitation, and a hail shaft would be, I believe your hail shaft is going to be strongest right here between your updraft and your downdraft. So here is, can you kind of see the onion effect? Kind of the different layers as this thing has traveled in the cumulonimbus cloud. I mentioned that hailstones can really fall fast, and they can. I think the fast-moving raindrop was 20 miles per hour, but check this out. Depending upon the size of the hailstone, its terminal velocity can be 77 miles per hour. You wonder, you know, how it does what it does to your cars. And there is a guy in, I think, a car lot. Maybe not. No, that looks like a regular license plate. But anyway, maybe you can see the damage done by hail to those cars. I mentioned rime is just a thick frost. Doesn't it look like just a thick frost? And it's beautiful. Maybe you can get a picture of rime. And like this says, supercooled water, though, was present in fog to create rime. I'll have to look for